let's learn how to expand logarithms. So the main three log properties you got to know in this video is a log addition property, where if you have two logarithms and they have the same base, well, what you do is you multiply the thing inside the parentheses together. The logarithm subtraction property is basically the same thing as the logarithm addition property, except there's a subtraction sign, meaning that you would have to divide the two things inside the parentheses. So once again, same base, but this time you divide. And for this property, the log bringing down exponent property, what you do is, if you have an exponent inside this logarithm, what you basically do is you just bring it down. So this is just equal to c times log base a of b. Now using these properties, let's try to expand some logarithms. So right over here we have log, and if there's no base written down, it's base 10, okay? So whenever you just see a log symbol, that just means that it's in base 10. So this is the same thing as log base 10 of 5 times 11. Now using the first logarithm property, well, what you do is when you have two things multiplied out together, right, log base a of b times c, well, what you can do is you can expand it out like this into its individual components. So in this case, I would just have log base 10, but I'm not going to write that because when it's in base 10, you don't got to write it out. Just put log there. So it's going to be log base 10 of 5 plus log base 10 of 11, right? So you just split it up into the two factors of whatever you're doing. The next problem, this is just using the logarithm subtraction property. What you do is, in this case, because you're dividing two things, right? You said how if you're dividing two things, well, you have to be subtracting these two logarithms. So in this case, this is just going to be log base 10 of 6 minus log base 10 of 11. So when you're doing expansion using the subtraction property, it's always the numerator minus the denominator, okay? Now this one, well, first thing I notice is that we have two things multiplied out together. So I can use the logarithm addition property, right? Because it's a product of two things. So I'm just going to get log base 10 of 2 plus log base 10 of 5 to the third power. Now the thing is, whenever I have something to an exponent and I'm talking about a logarithm, well, I said how we can bring down the exponent, right? So this is actually just going to be equal to log base 10 of 2 plus 3 times log base 10 of 5. So I essentially did there as I just brought down the exponent. And I got this. Next one, I have log base 6 over 7 to the second power, log base 10 of 6 over 7 to the second power. What is this going to be equal to? Well, one thing I can do immediately is, it's going to be annoying if I expand it out. I could just square everything. But one thing I'm just going to do is I'm just going to bring down the exponent, right? Because I have logarithm and I have this exponent up top. So I'm just going to drop the exponent down. So I'm going to go 2 log base 6 over 7. You could have also just squared both things. So you get 36 over 49. Same result. So now what you do is you expand this. Now, because once again, this is a fraction, right? So what you do is you write out the numerator, right? It's going to be the numerator subtracted by the denominator. Log base is 10 of 7. And now don't forget to multiply everything by 2. Because remember, this is 2 times log base 10 of 6 over 7, right? And log base 10 of 6 over 7 is all of this right over here. So that means that when you have this 2 in front, you have to multiply all of these terms by 2. So make sure you do that. That's one common mistake people do, is they only multiply by the first part. But you have to make sure you multiply by every part, right? Because this whole thing can be expanded. Now we have log base 10 of the square root of x. What is this? Well, if you need a little review on exponent properties, right? But whenever you have a square root of a number, you can rewrite this as x to the 1/2 power. Think about it. When you have the square root of a number times the square root of a number, you get that number, right? When you have x to the 1/2 power times x to the 1/2 power, using exponent properties, because you have the same base, you add up the exponents. So this is just equal to x to the first power, or just x. So you notice how, these two things are equal to each other. So I can rewrite this as log base 10 of x to the 1/2 power. Now you might be wondering, why is this so important? Well, now we have an exponent, right? And we're able to drop down this exponent. So we get 1/2 log base 10 of x. So whenever you have a radical, you can always convert it into exponent and make sure to drop that thing down. So next one, log base 10 of the cubed root of x times y. Seems interesting. Well, I'm just going to get rid of the radical first. I don't like that. So I'm going to do log base 10 of x times y to the 1/3 power. Okay? So if you have the cube root of a number, you can rewrite this as x to the 1/3 power. So whatever's inside the parentheses, all of that to the 1/3 power. I'm able to do this, and I drop down the exponent. So I get 1/3 log xy, x times y, log base 10 of x times y. Now this is the product of two things, so I get 1/3 times 1/3 times log base 10 of x plus log base 10 of y. Right? I make sure to put this in parentheses, right? We said how whenever we're doing these logarithm properties, and there's always like a coefficient for the logarithm, make sure to put the parentheses around it so you distribute to both of the terms. And finally, log base 10 of x times y times z. The thing about the logarithm addition properties, subtraction properties, is you can do it with as many terms as you want. So in this case, if I have log base 10 of x times y times z, this is just going to be equal to log base 10 of x plus log base 10 of y plus log base 10 of z. Right? So you can do this for as many terms as you want. Now, one common mistake people do, and this is regarding the this rule right over here when you bring down the exponent. Make sure that the exponent is inside the logarithm. You notice how right over here the exponent is inside the logarithm. So if I have something like log base 3 of 4 to the 5th power, I can drop down the exponent. However, if I have something like log base 3 of 4 and then 2 to the 5th power, so everything right over here is 2 to the 5th power, then I can't bring it down because the exponent is not inside the logarithm.